Hello, teacher. Alan. Today I will be solving an exercise for the numerical methods exercise. I will be solving the numerical methods extra point exercise. There we go. Okay, so I hope this is like okay. I'm just gonna be working here. It's nice. It's nice. So let's paste it. There we go. Just gonna go ahead and take it and put it over here. There we go. Put this a bit under here. Okay, there we go. Okay, so using numerical methods, solve using fixed point method. X plus e to the minus x squared cosine of x with initial value of -1. We're going to ignore the 0 because fixed point only requires a single initial value with an error of less than 1%. Okay, so first off, let's start by saying how we should solve a fixed point, a numerical method with fixed point. What we're gonna do is that we're gonna take our initial function, which is f of x, and we're gonna take an x in this case and make it equal to the rest of the function so that we get g of x. So essentially, we want the value of y in our graph to be 0. We want to find this specific point. And to do that, what we're going to do is take 0 equals x plus e minus x squared cosine of x. All right. And in order to find this, we're going to have an iterative process. But first off, we need to make a function with which we can do the iterative process. To do this, we're going to equal x to the rest of the function, as I already said. So we're going to have x equals minus e to the minus x squared times cosine of x. I don't know, it just comes out a bit crooked. I don't know why. Am I recording? I'm recording. Okay. So now that we have this, we're going to take our initial number and we're just going to plug it in as the value of x on this side. And we're going to see what the next x will be. And that's why it's called an iterative process. So we're going to make a line here. Okay, there we go. We're going to write our function x n plus 1 equals minus e minus x n squared times cos of x n, and that's it. Okay, so I'm gonna wait. I need to grab my calculator for this. There you go. Alright, so we plug in our first value, which is -1, and it's going to be minus e. Wait a minute. Okay, yeah. So it's going to be minus e to the -1 squared times cosine of -1 is going to be equal to, let me just do it quickly, minus e to the -1 squared times cosine of -1. It's going to be equal to minus 0.1987666. Okay, And now we're going to do this again, but with this value. So we're just going to e minus e. I'm going to simplify it for the sake of the exercise being easy to write down, but my calculator is going to do it with the whole value, so it's fine. So minus e times, let's do minus 0.199. It's, as I said, it's the same value on my calculator, so it's no problem. I'm gonna put the repetition function here, so it does it with the previous result. Squared times cosine of minus 0.199 is going to be equal to minus 0.942. Yeah, leave it like that. And we're going to do this a couple of times. Do I have to write every single one? I'm gonna do like 6 of them. Yeah, let's do 6. E minus 0.942 squared times cosine of minus 0.942 equals, do it again, 0. No, sorry, minus 0.2419242. Again, minus e to the minus 0.242 squared times cosine of minus 0.242. This is a bit tedious. I didn't like the numerical methods exam. It's so long. I mean, it would be fine if it was like with Excel, which you can like plug in the thing so it does it on its own, but no, I have to do it on paper. But it's fine. We'll just do it. This is gonna be a long one. Oh god, okay. Okay, I'm just gonna... Okay, may I skip to the chase? I don't know. Wait, minus 0.9156. Sorry. I'm gonna skip this. I'm just gonna write the results down. Okay, so then it's minus 0.263. Then minus 0.9007, and then again minus 0.2759, again minus 0.8917. We're closing in. We can see that the large is getting smaller. Yes. Again. Minus 0.284. Again. Minus 0.886. Again. Minus 0.289. Is it closing? Oh, ever so slowly. Oh my god. This is gonna take forever. Unless it's got like 2 0 points. That could be possible. Hold up, actually. It's not a bad idea to graph it So like we can wait, no, actually I can't do that during this. Okay, let's just keep going. Minus 0.882. It just keeps going on for a while like this. Actually, yeah, I think it's a good idea to graph it. I'm gonna change your vision here. Put that there. Oh, no, that's not. Okay, there we go. Alright, so I'm just gonna go to GeoGebra. There we go. GeoGebra Classic. X equal, no. X, what was the original function again? Wait. X plus e to the minus x squared. X plus e to the minus x squared times cosine. It was times, right? I'm not mistaken. Yep. Multiplication times cosine of x. And it has a single point. That's okay. That's beautiful. I mean, we are getting closer with time. It's taking a long while. All right, let's just keep going in that case. A 2, then it's gonna be 0.29. It's going up slower every time. I don't know if maybe I should start with 0. I'm not sure. Okay, let's start with 0. See what happens. 0, 0. Okay, it gives us -1. Oh, okay, it just goes back to the same thing. Okay, I'm just gonna do this. 275, 28. Okay. Okay, it just keeps going. That's unfortunate. 299. Oh shit. No, yeah. It just keeps oscillating between close to 0.8988 and 0.3. So that's a bummer. It keeps oscillating. I don't hold it. How do I solve this? Wait. Okay, there we go. How do you solve this? Damn. I don't know what to do. Oh, wait. Maybe the function has to be different. Perhaps. I mean, we could definitely try a different function. Let's try that, actually. Can you still see me? Yeah, okay. Let's try, instead of this, let's just do x. Okay, let's have this. Then we do x over cosine of x, like that, equals minus e to the minus x squared. And we're gonna do this minus x over cosine of x equals minus equals normal e to the minus x squared. Then after that, we're gonna do a natural logarithm on both sides. So ln minus x over cosine of x equals minus x squared. And for the final blow, it's just going to be minus square root. I'm just going to go directly of minus L and absolute value of x over cosine of x equals x. Okay, let's try this function instead. See if it converges any faster, because this one is clearly oscillating, which is not going to give us any results. Okay, so square root of minus natural logarithm of absolute value of x of minus x over cosine of x. Okay, and we replace x with minus 1. Okay, let's try this again. Oh no, it's damn it. It gave us a mistake. Yeah, because can't have a negative square root. Okay, this is I don't know what to do here. Hold up, let me do some research. I mean, yeah, it's there's not really any way. I don't think. Yeah. Okay, so if we are forced to use numerical methods by using fixed point, then yeah, this is not really solvable because it will oscillate forever and ever and ever. I mean, we could technically use a different method. Should I try that? I'm gonna try and use a different method. Hold on, let me remember how they are used, because I have forgotten over the course of a few days. I could use the Newton Raphson, maybe? Wait, hold up. I have to use the derivative. I don't want to use the derivative. Okay, yeah, essentially this just can't be solved with fixed point, of course. Yeah, I think that's about it. I'm just gonna leave it at that. Though we can see over here. Wait, I'm gonna bring you back to the graph here. Okay, there we go. We can see over here that the x-intercept would be around 0. X f of x equals 0. God fucking damn. Okay, wait. Hold up. Oh wait. Y equals 0. We do an intersection point between the two of these. Intersect between this one and this one. It's gonna have a value of around 0.59. So that's nice, I guess. I'm gonna send you an email asking if this is okay to send with a not conclusive, because it can't be solved with fixed points. So yeah, goodbye. Thank you.